All right, so today we're going to be making predictions using proportions. So I can use probability to make proportions. We've come off of the proportions unit, so now we're going to add on to that with our probability. So here are expectations. Remember to use twice the video's length to pause and take notes and to listen to what I'm saying so you can do it on your own as well, because you can do all this math. It's just the application of it that's a little new. All right. So after the video, here is our table of contents. So we are on predictions, which is page 14. And I'm going to pause it here. Okay, so I'm back. All right, going to page 14. All right, so this is again my second time filming this because it didn't want to load the first time. So, knowing that, here is our top. So title it predictions. It's page 14. Here's our learning target. I can use probability to make proportions. As a reminder, a proportion is a ratio equal to another ratio. In this case, and in all cases, they will be a ratio in fraction form, so ratio A to B, but in fraction and C to D, where A and C are numerators and B and D are denominators. So, moving on, we're going to make a fill-in-the-blank sentence. So that blank is proportion. Make a proportion to make a prediction. That is all that we're doing in these 4 next examples. We'll be writing proportions for the scenarios, and that will allow us to make predictions for what we expect or think would happen. So in the first example, we're going to be rolling a die 42 times, and I want to know how many times I would expect to roll a 6. So pause the video here. Now we're going to make a proportion based off of this. So 2 questions to ask yourself is, 1, on a regular roll, theoretical, again this is all theoretical probability, when I roll a die, what's the chance that I would expect to roll a 6 when I roll it once? And then how many times am I actually going to roll this, or predicting that I'm going to roll this? 42 times. So in my proportion, I'm going to set it up in this way where I have 1/6 is the chance of rolling a 6. Something out of 42 is the number of times I expect to see a 6 on my die. So when I have 1/6 is something over 42, this is a proportion. I have a ratio equal to a ratio. And notice that 6 times 7 gets you 42, so 1 times 7 will get you 7 times. I would expect to roll a 6 about 7 times if I roll the dice or the die 42 times. All right, and then on this next one, for example 2, you don't have to write this down, okay? This is just going to be a table or a bar chart that we're going to use for example 2. So notice that it has fruit on the bottom, on my x-axis, and number of people on my y-axis. So the nicest fruit, 35 people say that apples are the nicest fruit. 10 people say bananas are the nicest fruit. 30 people for oranges, 25 for kiwi, and 40 for blueberries, and 5 for grapes. So looking at that graph, we are now going to ask ourselves, whoop, I'm going to hide it, because yes, I want you to think about this and actually think about it on your own and not just look at my answers. So how many people out of 725 would pick orange as the nicest fruit? So I surveyed some number of people. You can count them up and figure it out. And how many of those people said orange was the nicest fruit? So we're going to pause the video here. 2 questions. 1, how many people said orange was the nicest fruit when surveyed? And 2, how many people in total were surveyed? So knowing that, this is going to be our proportion. We're going to have 30 people said that orange was the best fruit. 145 people in total were surveyed. But what if I was going to survey 725 people? How many would say they like oranges? So notice that this is a ratio equal to another ratio. So we have written a proportion here, and now we're going to make a prediction. 145 times 5 gives you 725. So 30 times 5 gets you 150 people that would be what I would expect to see in my survey is 150 people. It may be more, it may be less. This is just theoretical. Experimental probability would be actually going out and surveying the 725 people. Right now with this prediction, we're just using our brains and we're using past data. Okay? All right, so example 3 is where my video cut off the last time. So example 3, I have a bag of marbles and I'm going to pull one out, see what color it is, and then put it back. So that happens, and I draw red 23 times, green 18 times, blue 47, yellow 12. So count them up. How many times in total are being drawn? Okay, so let's see, 23 plus 18 would be 33, 41, 88. This should be 100 total. So I have 100 draws with replacement because I'm replacing the marble and then drawing again. So notice that with replacement. Okay, so we are going to do 2 parts to this. The first part is we're going to draw 625 times. Again, with replacement, and I want to know what's the chance, or how many times do I expect that red is not drawn. And if red is not drawn, what colors could be drawn? Green, blue, or yellow. Any of those 3 counts as not red. All right, so I know that typically not red happens. I'll change my color. Typically, not red happens 18 plus 47 plus 12 out of 100 times, okay? Because that includes green, gives me blue, and gives me yellow. All 3 ways are not red. So 18 plus 12 is 30, so that would be 77. So this is 77 out of 100 times. And I want to draw how many times now? 625. So how many times would I expect them to be not red? So we're going to be figuring out, what am I dividing by to get to 600, or multiplying, it's multiplying, never mind, multiplying, to get to 625. So using my calculator, what is 625 divided by 100? 6 and 2, 5, so 6 1/4. I'm going to do that 6 1/4 also up there. So I now want this multiplied by 77 equals, okay, so I would expect it to be about 481 times. Because that extra quarter, that 0.25, is not enough for me to round up. So I would assume about 481 times that I draw a not red. If I'm drawing and pulling a marble 625 times, are you going to do that? Does that make sense? No. That's why we're predicting, because no one's going to sit there for 625 times and just draw. So on that note, what if instead of just 625, we go all in and I want to draw it 1,000 times? Okay, 1,000 times. I want the chance that I am going to draw green. So far, in my normal 100 times, how many times do we draw green? 18. And now how many times am I drawing? 1,000. And I don't know how many times it's green. So pause the video, figure out the answer. Your answer should be, notice there's a scale factor of times 10. So it should be 180 green. It should be 181 times that you draw a green when you are drawing 1,000 times from the jar of marbles. Okay, we do have a 4th example, and if we didn't do it already in class, we're just going to stick it up here on the top in the margin, unless you have room underneath, totally fine. But if we did it in class, then you already have it in your notes. So, or we just did it in general. So this is example 4, And this is made up numbers. If we did it already as a class, then great, we get to use our actual numbers. But if we're making it up, we're going to make it up. So in our class, we have 32 students. All right. And 32 students, and let's just say 5 of them. Nah, I think more than just 5 of you. Well, maybe. We'll go with 5. Why not? I'm going to say 5 of you are only children. And you have no siblings, no brothers and sisters. So, only a child. And knowing that, what if there were 712 students at Edgewood or in our school? So if there's 712 students at our school, how many would you expect to be only children? So looking at this, we know right now what's the total in our little tiny group, our little sample. Our sample has 32 people. Of those 32, how many are only children or fit that criteria? 5. I'm going to pause the video. What would go on the other side of this proportion? So it should have 712 as our new total, and I don't know what would be in the numerator. And so now I have to figure out what is 712 divided by 32. 22 and a quarter. So I'm multiplying by 22 and a quarter, multiplied by 22 and a quarter. So I'm going to multiply that by 5. No! 22 and a quarter, multiply by 5, enter, and that'll be 111 and a quarter. So this will be 111 students, because I can't round that quarter up. So it's about 111 students is what I would expect to be only children at Edgewood. All right, so that fulfills our 4 examples. Again, here's our after the video. Were you focused? Do you understand what we did? Do you understand how we set up the proportions? Can you solve the proportion? And yeah, that's about it. So have a great day. Thanks for watching.